In this lesson, we're going to show another method of how to solve a quadratic by using the quadratic formula. The quadratic formula looks like a crazy formula, but really as long as you can kind of figure out where everything goes, we're basically using our standard form of our quadratic, the ax squared plus bx plus c equals 0, and we plug in our b, our a, and our c, and we basically use PEMDAS to follow through all the steps. You will definitely be using calculators at times for that, making sure that we can follow through the equation correctly. So here we are in example 1. We're going to use the quadratic formula to solve this quadratic, 2x squared minus 5 plus 3. Well, a couple things we do want to notice is that we are in standard form. We know that our a value is the 2. We know our b value is the negative 5, and we know our c value is the 3. So we have to keep that in mind when we're going to plug it in. So what we want to do here is start with this big formula, and it's important that you are writing this down carefully. You're making sure that the negatives go in carefully so that you don't make a silly mistake and then all this work is for nothing. So right away we're looking at negative b, but notice when b goes in it's negative 5. And we have to make sure that it's the negative of whatever the b value is. Then we do a plus or minus, because remember we're going to be taking the square root, and there are 2 roots to all of these. I would make a big long radical sign because we have a lot to put underneath there. We are then going to be doing b squared, and again we want those parentheses around the negative 5 to make sure the whole negative 5 is being squared. We're going to do minus 4 times a, which in this problem is the 2, times c, which in this case is a 3. So that is now the top part, or our numerator, plugged in, and down in the denominator we always have 2a, and a in this problem was also a 2. Now we need to start using our PEMDAS, making sure that we're really careful that we put down the right things for the right places. I'm going to combine a few things at once here. Negative 5 becomes a regular 5, positive 5. We're going to keep the plus or minus and the square root sign for a little bit here. Negative 5 squared is 25. And then I do negative 4 times 2 times 3 is 24. And in my denominator I get a 4. Now remember, the radical sign is like having a grouping, so the radicand underneath has to be completely simplified before I can go on and actually take the square root. So I continue with 25 minus 24, and we are all over 4. Now because of this plus or minus that we have, we are actually going to now have to split off into 2 continuing expressions. So we're going to have a 5 plus the square root of 1 over 4, and we're also going to have 5 minus the square root of 1 over 4, and that basically comes back to here by us getting 2 square roots, both not positive and the negative. So if we finish out these 2 expressions, I'm going to get 5 plus 1 over 4. That equals 6 over 4, which I know can reduce to 3 halves. And this one is going to give me 5 minus 1 over 4, which equals 4 over 4, which is equal to 1. So after all this is said and done, our solutions are x equals 3 halves, comma 1. So both 3 halves or 1 will be the solution to this quadratic. And again, if I decide to graph this, I should be able to find my 2 x-intercepts, or my solutions, or my roots on the 3 halves and on the 1. But that's how we can use the quadratic formula to get to the same solutions that we are looking for. Here's another example using our quadratic formula. And again, we're just going to get right to this one. Oh, I'm going to mess this up. Go into my pen. And I'm going to do x equals. This time my b value is a positive, so I can just put in negative 20. We're doing plus or minus, the big radical sign to give us some room underneath. Then underneath we're going to do 20 squared minus 4. My a value is a 4. My c value is a 25. And again, all of that is my numerator, and it is over 2 times a, which is 2 times 4. Moving on to the next step, and again, combine a few things in one step, keeping the plus or minus with the radical sign. I'm going to get 400 for 20 squared minus 4 times 4 times 25 is also 400, and that is all over 8. When I move to the next step, negative 20 plus or minus square root of 0 is going to be over 8. And then when I start looking at what this is going to do, so obviously when I take the square root of 0 on this next step, I'm basically going to be adding or subtracting 0. There isn't a positive or negative 0 answer, so really the 0 just kind of disappears. And we're given negative 20 over 8. Notice how we're not saying that we're done. It is just telling us that that radical with the radicand underneath becomes a 0, so we just move on with the numbers we have. And if I reduce negative 20 over 8, I get negative 5 over 2. What that does tell me with the radicand being a 0, though, is that I'm only going to have one solution. So in this case, our solution is going to be x equals negative 5 halves. Okay, on example 3, we're looking at more of a real-life application. We're trying to figure out when, after the year 1995, we had about 30 breeding pairs of the Rocky Mountain wolf. We're given the function that kind of models their population on how the breeding pairs are working. And as you can notice right away, the function is kind of a crazy one. It's certainly not something that we would even want to think about trying to graph or certainly factor. So this would definitely be a perfect candidate to try to talk about using a quadratic formula. Well, the first thing we got to notice is when we have our function over here with the y, we need to kind of figure out, well, what are we talking about here? This y is the number of breeding pairs. So we know what we're looking for. We're looking for the time when that y is a 30. That is the y that we're trying to find. What we're looking for, though, is the number of years since 1995 that will actually produce that 30 breeding pairs. So what we have to do very first is to kind of rewrite our formula here to solve it for 30, which simply means put the 30 in the equation, subtract the 30 from both sides to create our 0. That is an ugly line there. So the function that we're actually going to be putting into the quadratic formula is this one right here, which is a little bit different than the one that we started with. But this function has now kind of been reset for the 30 breeding pairs. So now we don't have the initial A, B, and C. We have new C's with the A and the B still being the same. So now we can come over to our quadratic formula and plug in our values. Our 3 is where the B is. So I'm going to plug negative 3 plus or minus the square root of 3 squared minus 4. The A value is the 0.34, and the C value is negative 21. Then I would plug in 2. Our A value again was the 0.34, or 34 hundredths. Okay? When I move on to my next step, we'll change color just so we can see the difference here. Negative 3, still plus or minus. When I go inside my radical, I get 9 minus, and I didn't just do this one in my head. I used the calculator and already had it ahead of time. 28.56. And I made a mistake here. Let me just fix that before I go any further. From the first step in the red, we had a negative 4 times 34 hundredths times negative 21. So before I go on, just make sure I notice that that should be plus. So it's 9 plus 28.56. That would have been a mess, and that's one of those areas that if you don't catch that when it happens, you can go all the way to the end, think you have an answer, and you are actually not correct. When I move on to the next one, Now I can simplify the radicand a little bit further. The 9 plus the 28 is going to give me 37.556, still all over 0.68. Now I've got to think about actually using the calculator and doing my square root keys. So over here, this is going to produce two different equations for us. X equals -3 plus or minus 6.128, again divided by 0.68. It's also going to give us x equals -3 minus 6.28, 1.28, 0.68. Now, even before I use my calculator, a little bit further on that one to the right, one of the things that I hopefully see, and you'll see as well, when I look at this right here, I end up with a -3 minus 6.128, which is going to give me a negative number for my numerator. I'm dividing it by a positive, and so because we won't want to have negative years, we are going to take this right out of the picture. Okay, so now we can really just go back to the first one here and focus on what does this expression right here give us, the -3 plus 6.128, and then divided by, in reality here I'm going to also take out this little thing here because we don't really need that there. It is plus on that one, the negative one is the one we're throwing away. When I run this through the calculator, x equals, or is approximately 5, and because we are looking at the number of years after, what we are trying to find is how long it's going to take to get 30 pairs. It is approximately 5 years after. So now we want to focus a little bit on some of the pieces to this. When you look at the quadratic formula, the expression that's underneath the radical, or in the radicand, the b squared minus 4ac. This expression is called the discriminant. And the discriminant is an important thing because it kind of can quickly tell you a couple of things about your equation. It can tell you before you start working on this long, crazy formula the number of solutions that your quadratic should have. And the way that that works is that if you look down at the graphs here, we have a couple different things that are happening. So when I see a discriminant where the left side simplifies as some number that is greater than 0 or a positive number, you know that once you take the square root of a positive number, you end up with two square roots, both the positive and the negative. So that will mean that you will end up with two solutions, or two x-intercepts. Anytime that you are looking at a b squared minus 4ac that equals 0, that will then tell you, which we saw in the previous one of the previous examples, that'll then tell you you only have one real solution, or one x-intercept. So when your b squared minus 4ac equals 0, that tells you you would have one intercept. And then lastly, anytime you have something where your discriminant ends up being less than 0 or a negative number, that would then tell you you do not have any real solutions. We talked about how no real solutions because you can't take the square root of a negative number. So when the discriminant is negative, the entire problem is kind of done at that point because you can't do the square root with a real number. So all we have to do on these is, so this next few examples are the following. We already have all of the letter A in standard form, so we can just again focus on A, B, and C. So what we want to do is just take our discriminant, and basically we're just trying to find out in this case what is the number of real solutions. They're not asking for what they are, so we're going to take our discriminant. The B is 8 squared minus 4 times 1 times C, which is a -3. And when I combine these with my order of operations, we'll get a little more room right here. I end up with 8 squared, which is 64. So let's just change that. We get 64. Negative 4 times 1 times negative 3 is plus 12. So we end up with a positive number, and that positive number is 76, which is really not really important at this point. It would be if you were then continuing on to find how the actual solutions, but because it's a positive number, we're going to have two real solutions. So it's not like the work is for nothing, because that 76, if I was then to say, well, find them, then you already have the 76 to plug in for the entire expression, and then you can just go into your quadratic. So on the second one, we have a little bit of work to do because this is not in standard form. I would strongly suggest that you make the move here to move over the 6x. There's a lot of times that people will say, well, I don't need to move that over because I know that that is going to be something that I can do in my head. And this is a lot of times where by not moving it over, you plug your b value in as a positive 6 because you see the 6, or even sometimes you plug in a 7 because you see ax squared plus bx, and even though you know that there's nothing with the 7, a lot of times we see that mistake where you plug in a 7. Put it into standard form so that you can see exactly what you are dealing with, and at that point then you can just say, well, my b squared is going to be negative 6 squared minus 4. A value is a 2, c value is a 7. When I do this negative 6 squared, I get negative 36, and then when I subtract, I'm subtracting 56, which is going to give me a negative 20. And what we said was, if you had a discriminant that was a negative number, what that is telling you is there are no real solutions. So basically we've done a lot of work here in this little section, and actually this whole entire chapter. We've shown you some different ways to be able to solve quadratics, and all of them are important, and all of them you will be able to use at different points depending on the information you're given. So here is the quadratic formula, which works for every single quadratic that you are trying to solve, whereas the factoring and the graphing not always can be used the same way, but quadratic formula will work for them all. Just a matter of trying to be careful in your calculations.